So just to kind of give you guys some perspective, this is Wyoming. It's a rectangle. What's that? Good. That's the Black Hills. What's that?
Double Star.
Nope. Bighorns. Bighorns. What's that? Jessica?
Owl Creek.
Yep. Owl Creek. That's the Wind River Range. This is a little awkward, but these are the, it's not exactly right. This is the Absaroka Range. It looks like Absaroka, but it's Absaroka. And then these are the Tetons. And then down here are the Uintas. So this is, there's some weird things going on. Notice that the axis of a lot of these, and then down here is the Front Range, Uncompahgre, the Uncompahgre Uplift, Sevier. See this? Look at the axis of all of those. Where's the stress direction? Yeah, east-west. So it's like compressional this way, except for the Tetons. So, yeah, I mean, yeah, they're not compressional. But we'll talk about that. But notice, like, look at the Uintas are going the wrong way. The winds and the medicine bows are like this kind of curved shape too. So there's some interesting, like, large scale tectonics going on that have changed the stress field here. Okay, so that's really big picture. The other thing, so this is why I wanted to stop here, because now we're going to be getting into the good icy stuff, and you're going to see some glacial features. So the thing I want you to keep an eye out for is, all right, this is a mountain, and you have a low area in the mountain. I don't know, just for some reason, maybe there's a landslide or something, and it fills in with snow. Fills in with snow, and it's on what side of the what side of the mountain is it on?
So the base is the south.
Yeah, it's on the north side. It's on the north side of the mountain. So in a cold year, that snow was pretty thick from that past winter. Maybe they got 60 feet of snow that year, and only 40 of it melts, and there's 20 feet left in this depression, and it's on the north side, and the snow stays, and then the next winter comes and we pile more on, and eventually this gets thick. It's all frozen together, and what starts happening to this big block?
The snow at the bottom starts to compress into place.
Okay, so it's
starting to shrink.
It's melding kind of into itself. What else?
It might start to sort of like break off in sheets from
If it's all frozen together, but it's on this relatively steep slope,
it's gonna just fall.
Yeah, it's gonna start like wanting to go this way, and so, but it's frozen. It's frozen to the rock. So it actually starts to like peel the rock away. And then the next winter comes and it fills in that area that peeled away, and it starts happening again, because the bigger that thing gets, the heavier it is, and it starts to want to pull due to gravity. And each time it's pulling away from the wall. See that? So there's my hillside is the blue, the ice is red, it pulls away because it's a big mass of ice and it starts sliding down. This is a head crevasse. Has a great name. Anybody want to wager a guess? You've had geomorph, you might know this.
Isn't it something about like the...
You're sitting in the van.
It's a Bergstrand.
I just said that like 20 minutes ago.
This is that head crevasse as the glacier pulls away from the wall. It opens up a crevasse here. Meltwater goes in there, snow, more meltwater, and it forms this ice wedge that, again, freezes onto the glacier and to the rock, pulls again. So over time, what's happening is that little pocket of ice is eating in and now this is all full of ice. It's, you know, the big bowl-shaped depression. That is a cirque. C-I-R-Q-U-E. From above, that cirque has maybe like a ridge line. So now you're looking down on a ridge line and here's a peak. Okay, can you guys like make sense of what I just drew? Kind of like a pyramid, like a triangular shaped peak. There's the peak, and this is one side of the mountain. Let's say this is the north. Let's say this is the north side of the mountain, and that cirque is going to create this bowl shape, and the ice is all in there. This is all ice, and it's going to flow down slope. And it's going to continue to make that cirque bigger. Okay. What's that?
So doesn't it form like a horn?
Yeah. Now let's put a cirque on this side and a cirque on this side and have each of them continue to erode back towards the peak, and you get a horn.
Is that where the Matterhorn comes from?
That's the Matterhorn. The Matterhorn is a horn. It is where the Matterhorn is three-sided. It's where three cirque glaciers came together. Okay? The knife edge where two cirques are side by side is called an arête. So we have cirque, an arête, A-R-E-T-E, okay, and a horn. And we'll talk about a coal, and we'll talk about a trough, and all that stuff in the next couple of days. So we're gonna have some good glacial stuff, but I want you to pay attention to what you see in the high mountains as we go, especially you guys in the back of the van, look back this way. Look how much freaking snow is on that slope. And what side of the mountain is that? Yeah, it's basically the northeast side. Yeah. Okay. Yep. So this side has snow on it, but not as much. It's south facing. It's also at quite high elevation. I bet if we went on to the other side, there's probably 3 times as much snow. Okay?
What did you say the neve was?
That's like the incipient glacier. It's just getting started. I'll talk a little bit more about it.
Like a baby cirque?
It's the start. Yeah, it's
Okay.
you can call it a baby cirque. But it is like a neve is literally it's the patch of snow left over that makes it through the summer.
Okay.
So wait, when we were driving up through the Bighorns, there were small patches of snow left in the higher rolling hills. Would those count as neves?
Not now.
It's too early in the
If they're
year.
still there.
If they were there in August,
Yes.
yes.
But now,
No. But that's how glaciers start. That feature. Leave it there through August and you eventually develop a glacier. Okay? All right, look for ice.